Okay, now let's plot some error bars. So far we've used the plot command from matplotlib. Now let's use the error bar command, which is just error bar, if I spell it right. Now we're going to need to tell it what the errors are. So the errors are in the y-axis, so we'll type y error equals, and it's going to be data.uncertainty, because it's the column labelled uncertainty. If I can spell that, insert. So this is telling it to look for the y error bars in the column of data called uncertainty. There's also one other minor change we need to make. For the error bar command, you can't just type the format like this, you have to call it format, fmt equals. Use the same syntax, just need to tell it it's the format. Okay, let's try this, shift enter. And now we've got error bars in y. Another thing we can do is we can do arithmetic with our different columns. For example, here we're plotting the redshift. What we'd really want is to plot on the x-axis data.d, which is the distance to the supernova, and on the y-axis we want to plot the size of the universe, which it turns out is 1 over 1 plus the redshift. So what it's doing is it's computing a new set of data, each of which is 1 over 1 plus the old data. And that's going to be the distance. And this is going to be scale factor. And now the errors are going to be in x, not y. So let's do it this way around. And if you run this, so you can do arithmetic with different columns, you can add columns together, multiply, divide, do any function you like using all the mathematical stuff that's in Python. You can plot error bars in x or y, you can change the formats as you like. These data actually is what got Brian his Nobel Prize. What we're looking at is the size of the universe as a function of time. When we look at a very far away supernova, we're seeing it as it was when the universe was very much younger, a long time ago, because the light has had to travel so far. So this is like age, and what we're plotting vertically is the size of the universe. And what we can see is the universe started off about half its current size, the furthest back our data goes, and it got bigger and bigger until it's now at its current size, and indeed the universe is expanding. What you can see is it used to be expanding more slowly, but the gradient has got steeper, and that's the evidence for dark energy, which got Brian his Nobel Prize. All done using Python plotting.